Square roots and cube roots, lesson 3 notes. Example number 2. Find the solutions to each by rounding to the nearest tenth. Do me a favor and underline the word tenth. All right? Why do we have to round on these? Well, the reason why we have to round on these, because unlike example number 1, where the original numbers are all perfect squares, example 2, the original numbers are not perfect squares. And if you remember correctly, when you take the square root of a number that's not a perfect square, you get an irrational answer. Because it's irrational, we're going to have to round it. When we round, we use this symbol right here. That is the approximate sign, or the approximate symbol. Okay, so it's kind of like an equal sign, but the lines are squiggly. So take a moment, pause your video, and write that down. So the approximate sign means that it is approximate, or you could also say about. Okay, the inverse operation of squaring a number is the square root. So I'm going to take the square root of both sides. Go ahead, pause your video, and show that you take the square root of both sides of each equation. Right, let's start with A. Let me pull up my calculator. All right, I'm going to take the square root of 30. Well, the square and the square root would cancel out. And in the calculator, I get x equals, now remember this is a square root, so I need both the positive and negative root, 5.4772. So 4 decimal places and then the ellipse. All right, now it's asked us in the direction to round this to the nearest tenth. So that would be this decimal place. The 7 would push the 4. Now because we're rounding, we need to use the approximate sign. So x is approximately positive and negative 5.5. X is approximately positive and negative 5.5. Okay, let's try B. Again, the opposite of squaring a number is the square root, so I can cancel those out. I'm going to take the square root of 110, and I get 10.4880 in the calculator. So, positive and negative 10.4880. Remember, 4 decimal places with the ellipse. And we didn't round yet, so I'm going to still use the equal sign. Why? Now, if you can keep the equal signs lined up on these problems, that would be wonderful, but I really understand that there's not a whole lot of space, so if you need to, you can go ahead and, in this case, not keep the equal signs lined up. All right, now, I need to round my answer. I'm rounding it to the nearest tenth. The 8 would push the 4, so my final answer is positive and negative 10.5 is approximately, don't forget your approximate sign, y. Okay, let's do one more together. You'll do the last one on your own. So for C, again, the square and the square root cancel one another out. I take the square root of 20. I get 4.4721 and so forth. So I'm going to put z, and please put a line through your z. Z equals positive and negative 4.4721. Put the ellipse. And now we're going to round that to the nearest tenth. So the 7 would push the 4. So z is approximately positive and negative 4.5. Okay, take a moment, pause your video, and try D. Try doing problem D all on your own. Okay, for D, take the square root of both sides. That allows me to cancel the square and the square root. Try that again. Put the square root of 500 in my calculator, and I get 22.3606 and so forth. So positive and negative 22.3606, put the ellipse, equals W. Now I'm going to round it to the nearest tenth. The 6 is going to push the 3. So my final answer will be positive and negative 22.4 is approximately W. Again, don't forget to use your ellipse with the equal sign. Make sure each of your final answers has the approximate sign. And make sure you have the positive and negative in front of each one of your answers. If you have any questions on example number 2, please let me know.